Alright, hello everybody. Welcome back to another edition, Algebra 2. I'm Mr. Anderson, here as your tour guide through another section of Chapter 4. We're in 4.2 today, solving quadratic equations by graphing. That's all we're going to be talking about today, is graphing them and see how we can use that to solve. First up today, Family Channel. Okay, got my Family Channel shirt on. Just for December, and so this is in honor of December here. I got my Family Channel shirt on. Alright, well, let's get started, and let's see what our objectives are, first of all, for today. Our objectives are going to be solve quadratic equations by graphing, and secondly, estimate the solutions of quadratic equations by graphing. So basically, we're going to find out specific ones, and then we're going to have to estimate on some of them. That's all. Alright, first of all, quadratic equations. We've been talking about quadratic functions, but a quadratic equation is just when we take one of these functions and set it equal to a value. And an example of that would be this. This is the standard form of a quadratic equation. Ax squared plus bx plus c equals 0. Okay, so that's the standard form there that we're talking about. And our solutions, aka roots or zeros, I feel like I'm in a cop show there, aka roots, aka zeros. 10-4, breaker 1-9. Anyway, the solutions or the roots or the zeros, aka, are going to be the x-intercepts of the graph, or where our graph crosses the x-axis. Okay, that's really, this is the main thing. Okay, right now today, if there's one thing that I can emphasize, it's this: that the solutions are the x-intercepts. Okay, that's the main thing that we're going to be talking about today. All right, here are the potential situations that you can get in when you're solving a quadratic equation. Remember, the graph makes a parabola, and so here's the different possibilities. First of all, you could have one solution where the parabola does this and it touches right at the x-intercept, or the x-axis there, and it's just one solution. Probably most of the time you're going to get something like this, where the parabola goes down, touches once on the x, and then comes back up and touches again. It'll touch in two places. That means you have two solutions. And then it could also happen where the parabola will not touch the x-intercept or the x-axis here, and you would get no solution. Okay, so those are the three potential things that could happen. So let's go ahead and take a look at some of these. Alright, example number 1. Here is our equation, x squared minus 3x minus 4 equals 0. Remember a couple of things here that we learned about before. First of all, this remember this negative 4 here? That's your y-intercept. So we know already we could go 1, 2, 3, 4. We can put a dot right there. And then what might also help us remember to find the axis of symmetry. X equals the opposite of b over 2a. And so b is negative 3, so the opposite of negative 3 over 2 times 1. 1, remember 1 is a here. So this is going to be 3 over 2. Ooh, interesting. Remember before in the last section everything we did worked out kind of nicely. This one doesn't work out really, really nicely. And so 3 halves, that's the vertex, you know, the x-coordinate for the vertex, which is 3 halves is really what? 1.5 or 1.5. So what this means is our axis of symmetry here is going to be, it's going to go right here through 1.5. And I'm going to try to draw this the best I can, like a dotted line here. So that's going to be the axis of symmetry. And so we know that that's kind of where everything's going to get reflected across. So then let's punch this into our calculator to get the rest of the points here. Make it easy on ourselves. So remember, go to the y equals button. So go to the y equals button, and then we're going to type in, just like we did before, even though it equals 0, you know, just type in y equals and then the x squared plus 3x minus 4. Just type that part into your calculator. So you've got x squared minus 3x minus 4. Second function table, and I did something wrong. Let's try that again. Let me just start over. X squared minus 3x minus 4. And so remember, 1.5 is your vertex there. And so you want to kind of look around that. And I notice here, I'm going to make a little table of values to show you what was on my calculator here. So what I got here was that I've got a point of 0, negative 4, and then 1, negative 6, 2, negative 6, 3, negative 4. Oh, and I should add one here kind of up at the top. Yeah, I didn't leave room for it. But there's a point of negative 1, 0, which really kind of should fit up here. And then there's a point of 4, 0. And the reason why I included those, I went a little bit further than I normally did, was because those are important points, which we'll see in a second here. So when I graph these, I've got 1, negative 6. So 1, 2, 3, 4, 5, 6. Here's 1, negative 6. And then I've also got 2, negative 6, which is about right here. And then 1, 2, 3, negative 4. Negative 1, 0, which is right here. And then 4, 0, which is right here. And if we wanted to, it's probably not super important at this point, but if we wanted to find out what the actual vertex point is here, we could plug in 1.5 back in to this and find out the exact point there. But it's just going to dip a little below there, and for our purposes right now, it's not really important, because our purpose is... Ooh, that was pretty good, except for the beginning. Our purpose here is to see where our graph crosses the x-axis, which is right here and right here. And so that gives us two solutions. And by the way, by looking at the table here, you can see that our two solutions are negative 1 and 4. Those are our two solutions. So in this case, we graphed it, and the two places where it crossed the x-axis there are our solutions. Negative 1 it crossed and 4 it crossed. And you can also see that in the table. Wherever y is 0, the number that goes with it, that is the solution, or the root, or the 0, aka. Okay? Example 2. Well, let's look at another one here. Do the same thing. But if you notice here, not like it's a big deal, but in order to be able to tell some things here, notice this is equals a negative 4. And so what we might want to do here is go ahead and do plus 4 to get all this stuff over on the same side, because then I'll have x squared minus 4x plus 4 equals 0. And you can see then that positive 4 will be the y-intercept there. So 1, 2, 3, 4. Okay, so you might get fooled and think, oh, negative 4. Now remember, get it over with the other stuff there. Okay, let's just find our axis of symmetry again here. Opposite of b, remember b is negative 4, so that means it's going to be 4 over 2 times 1, which is 2. So that means our axis of symmetry is going to be at 2. Okay, so it's going to be right here. And then again, let's just punch some stuff in and find our table here. So again, I'm going to go to the y equals button, I'm going to plug in x squared minus 4x, and this time it's going to be plus 4. Second function table. Now remember, 2 is our axis of symmetry, so we want to find the points that are on kind of both sides of this for our table over here. So let's look at, well, we've got a point here kind of right in the middle, actually, of 2, 0. That's going to be this point right here. And then I've got a point of 1, 1 right here. And I've got a point of 3, 1 right here. And then 0, 4, which, hey, that's the y-intercept. Remember the y-intercept there, 0, 4. We've already done that. And then the other one here on the other side is 4, 4. So we also have 4, 4, which is going to be right up about here. So you go, well, here's our graph. Okay, so we graph that. And now when you look at this, you go, well, remember the solution is where it crosses the x-axis. This time it only crossed in one place, right here at the vertex. So this is this time when we only have one solution. And in this case, our solution is just 2. 2 is our only solution there, because that's the only place where it crossed the x-axis. Okay? We getting a feel for it? All right, example 3. Once again, you notice, hey, I've got a minus 8 over here. So let's go ahead and move it over. Plus 8, plus 8. This is going to give us x squared. Oops. Yeah, let me do this. I think I can do this to make it nicer. Okay. Go to my eraser there. Look at that. I'll erase that one too. All right. Okay, this seems to have a mind of its own right now. I'm going to try to get my pen back. Okay, so minus 6x plus 12 equals 0 this time. So when we graph this one, 12 is going to be the y-intercept. That's kind of off our graph here, so hopefully that won't make a difference that we don't use that point. Let's just use what we can, and hopefully the rest of it will be okay. So remember, x equals the opposite of b, so the opposite of negative 6 is positive 6 over 2 times a, which is 1. So in this case, 3, our axis of symmetry is 3, so 1, 2, 3 is going to be right here. And again, I'll just draw it so we kind of have something to go on here. So our parabola should reflect around that. I'm going to go ahead and plug some points in here, or plug the equation in into the y equals button. And I'm going to type in x squared minus 6x plus 4 or plus 12. Second function table. And so remember, it's going to center around where x is 3. So here are the points that are critical for me. So here's my xy table. I've got a point here of 3, 3. That's going to be the vertex. So I'm going to go 3 and 1, 2, 3 is going to be right here. And then I've got 2, 4 and 1, 7, and going the other way is going to be 4, 4 and 5, 7. Alright, so let's look at those here. 3, 3, and then I've got a point of 2, 4 and a point of 4, 4, and then I've got a point of 1, and then 1, 2, 3, 4, 5, 6, 7, and then 5, 7, and if you look at this graph, It doesn't cross the x-axis anywhere, does it? So what happens here? No solution. Okay, so that's an example of no solution because it does not cross the x-axis. One more example and we'll be done. All right. Okay, in this case, kind of all ready to go because it equals 0 there already. So it looks like we've got, where's my pen? -1 is going to be our y-intercept. So we got a point right there. We can just go ahead and put that in. Let's find the axis of symmetry here. So remember, x equals opposite of b. So this time it's going to be a -4 over 2 times a -1. So this is really a -4 over -2, which is going to be a +2. Okay? So here's my axis of symmetry. Draw a dotted line here. And then let's find our points here, our x and y table. So I'm going to go ahead and type in a negative x squared plus 4x minus 1. Second function table. And remember 2 is the vertex, and so the x coordinate for the vertex is 2. And so the point there, which will kind of be in the middle here, is 2, 3. And then I've got a point of 1, 2, 0, -1. And then I've got 3, 2, and 4, -1 are some points here. So let's look at this. And I've got, remember the vertex here is at 2, 3. So at 2 and then 1, 2, 3. Put a dot. And then I've got 1, 2. And of course 0, -1. We already got that one. And then I've got 1, 2, 3, 2. And then of course 4, -1. Alright, so now you see, if I draw this, what's going on there now? If you look, and you maybe could have figured this out from the table before I even drew it here, but especially when I draw it, look at this. Here's the graph. It comes down. Where does it cross the x-axis? It crosses in 2 places. We have 2 solutions, but it doesn't cross at a good place, does it? So this was that second part, the second objective we had at the beginning where it said we estimate the solutions, and it's really not that hard. Basically all we're going to do here is if it doesn't cross at a good spot, then we're going to say this spot right here, what x values is it in between? It's in between 0, which is right here, and 1. So when we say our answer here, we're going to say between 0 and 1. So it's somewhere between 0 and 1 on x. And then we go over here, it's 1, 2, 3, and 4, and it's somewhere between 3 and 4. So 1, 2, 3, there's 3, and there's 4. So somewhere in between 3 and 4. And when we say these here, remember, these are the x values. Somewhere between where x is 0 and 1, and between where x is 3 and x is 4. That's all we do. So nothing really tricky. Just if it doesn't give you a good, perfect, easy spot to tell what x is, then just tell what x's it's in between is basically all you're doing there. Okay, so that's the main gist of this whole lesson today is we're just graph the quadratic equations and see where they cross x. And the solution, or the roots or the zeros, aka, are the places where they cross the x-axis. Okay? So that's it. Good job today. Thanks for being here, and we will see you next time. Au revoir.